Hi everyone, this is Fahad Mirza and I welcome you to the channel. In this video, we are going to have a look at Thera, which is a new approach for arbitrary scale super resolution. This represents a significant advancement in the field by integrating classical signal theory concepts and modern neural representations. Let me show you a quick overview. So for example, if you look at this left image, this is not really a well formed image, but if you use Thera on it, look at its resolution. So this is the original image and this is the image after we apply Thera on it. Similarly, look at this example. Check this out. And there are various examples which they have shared on their project page. Now before we get it installed and play around with it, let's have a very quick overview on its architecture as you can see in this diagram. So this Thera, this has introduced neural heat fields which inherently encode a physically accurate PSF within the neural field itself that ensures correct and theoretically ideal anti-aliasing. The neural heat fields leverage sinusoidal activation functions to control the individual spatial frequency components precisely that enables exact computation of Gaussian blurred version of images at arbitrary blur radii analytically. I know it's a mouthful, so just ignore what I said. Don't worry about it because what I'm going to do, I'm going to show a very simple example to you after installing it, and then we will play around with it. So for the conceptual side of things, just remember this, that Thera is the first arbitrary scale super resolution model with built-in physical observation mechanism. That's it. So let's try to get it installed and we will see how it works. Let me also give a huge thanks to Mast Compute who are sponsoring this VM, Ubuntu 22.04 and this GPU card, NVIDIA RTX A6000 with 48 GB of VRAM. Let's start by creating a virtual environment with Conda. And meanwhile that happens, let me also thank our very good friends at Camel AI who are sponsoring this video. Camel is an open source community focused on building multi-agent infrastructures for finding the scaling laws of agents with applications in data generation, task automation, and world simulation. And now let's git clone the repo of Thera and we will cd into it. And I will also drop the link to it in video's description, so don't worry about it. Next up, we need to install all the prerequisites from the root of the repo. And this is going to take a few minutes, so let's wait. Okay, so everything is installed and now we can launch our Gradio demo. For that, all you need to do is to run this script from the root of the repo and then we will access it in the browser. And there you go. The first time we are going to run it, it is going to load these couple of models and now we can access it on our localhost at port 7860. So let's do it. There you go. So this is running and now we can play around with it. So I'm just going to select one image from my local system. Maybe I will just go with this animal one first, if I could find it quickly. I'm just searching for a starting image just to show you the proper. There you go. So this is a zebra image which I have just uploaded. It is working on it. Let's also check VRAM consumption in real time. So consuming just 3.7 gig of VRAM, not bad at all. And look at this. So let me first show you the original one. This is the original image and this is the super resolution image. Is it? And it is arbitrary. So this is really good stuff. Let me actually open it in the this is actual image. Sorry, you can't see it. Maybe I can make it bigger. There you go. So this was the actual image and look at how much enhanced this image has become with the help of this model. Okay, let's try out another one. Okay, how do I remove this? I don't see any X button here, so maybe I would just I'm just clicking on it. Maybe clear. Okay, there you go. Okay, let's try out another one. So there is another building. Let's check out the building image. How does that look? Yeah, not that bad, but still I think improvement can be done. Let's check it out here. There you go. So let's first check the blurry image. Now let's check what model has done. Oh my goodness, this is so cool. Real good stuff. Okay, let's clear it, and we can tinker with these parameters, and these are some of the sample images which you can also use, and I have also taken some. But let me try out now one of my own. Let's try this one. Let's wait for it. So it is just showing you some of the logs. There you go. Let me check. Okay, so you see this is where it is struggling. So this is one of my own image which is inherently blurry, very blurry, and it couldn't do it. We are pushing the limit of the model here. Okay, let's try out another one then. Maybe I will just go with these blurry people. Okay, so the size should be 600 by 600 pixel, and it is, I think, way more than that. So I'll just clear it. Maybe, okay, so there is another limitation which we just stumbled upon. And let me check this blurry vision. Again, this one was quite big. Okay, so I think this is one limitation of the model. Maybe I'll go with this one then. Let's wait for it. And there you go. Let's check it out. So this is a blurry, and look at the super resolution. How cool. It's just like a magic paintbrush. So look, when it works really nicely. But if we can respect its limitation around image size, and if the image is not inherently very bad, works pretty well, I would say. And we have to remember that this is the first iteration of this model, so I am really hoping that down the road it is going to improve a lot, and it is going to support more and more bigger image sizes. I will drop the link to it in video's description. Let me know what do you think about this project. I am very impressed at the starting, and I think really good stuff in terms of image resolution enhancement. Let me know in the comments what do you think. If you like the content, please consider subscribing to the channel. If you're already subscribed, please do me a favor and share it among your network, as it helps a lot. Thank you for all the support.